Hey everyone, in today's video we are going to do something really cool. We will take a regular video clip and transform it into a panoramic image. By the end of this video you will know how to extract frames from a video, stitch them together and generate a wide panoramic view from a moving footage. This can be super useful for photography enthusiasts, videographers or anyone who wants to create immersive wide-angle shots from videos. We will be using Python as our primary programming language here. The main libraries we will use are OpenCV, which we will use for video processing and image stitching, NumPy for handling the image arrays, and finally Matplotlib library for displaying those images. We will also use Google Colab here for simplicity, so you can upload your video and run the code without installing anything locally. Here's the video clip that we will use today. A huge shout out to the owner of this video. I would be attaching the link to this in the description box below, where you can download that for free or use any clip of your own choice, including the ones you shot yourself. Our aim is to convert this moving video into a single panoramic image frame. As you can see in your screens, this is the image that we stitched out from the video. You'd be able to do this with any video of your own choice. Before we code it down, let's understand how we plan out the code. So what's our idea behind the code that we want to write for generating the panoramic picture from a video? Let me show you a theoretical walkthrough of the idea behind the code that we want to implement before actually coding it down. The first step is the frame extraction. First, we will break the video into individual frames. We don't need every single frame, so we will skip some frames for enhanced performance. The second step is the image resizing. We will resize the frames to a manageable resolution so that stitching is faster and memory efficient. And the third step is the image stitching, where we will finally use the OpenCV stitcher to align the overlapping frames. It detects key points to consecutive frames and matches them to create a seamless wide-angle panorama. Going through these three steps, the algorithm combines multiple viewpoints from the moving camera into one wide panoramic image. We will divide our entire process into 6 key steps. First, we will upload the video. After that, we will extract every 10th frame. Then, we will resize the frames for faster processing. The fourth step would be stitching the frames using OpenCV Stitcher. And the very last one will be displaying and saving the final panorama. We are done planning our steps, so now let's get into its application. First and foremost, we are going to need these 5 necessary libraries in order to accomplish our task. The first one is the OS library, which we will use in order to check whether if a file exists or not. The second one is the CV2, also known as the OpenCV library. This library is mainly used for computer vision tasks, and here we are going to use it in order to read the video, extract frames from it, and also stitch those frames up in order to form a single panoramic image. The third one is known as the NumPy library, and here we are going to use it mainly for image array manipulation, because the OpenCV images are mainly stored as NumPy arrays. The fourth one is the Matplotlib library, and we are going to use it in order to display the panorama image in the Scholar file. And the very last one is needed in order to upload the files from our local machine to this Scholar file. The next thing that we want to do is we want to upload the video file here. For that, I have written some code which I will paste it here, and when we run it, it gives us the option to choose a file from. So we will choose our file. I'm choosing this one, and you can see the upload has begun. The file size is huge, and for that reason it's taking a bit amount of time, so I will get back to you after we are done uploading. We want to create the function, and we can name it anything. I will name it process video for pano. So this function will actually process the video and return the frame out of it. The panoramic frame out of it. Within the parentheses, we will pass the video path. And the first thing that we want to do is we will see what happens if we do not find any file. So in that case, we will write if not os.path.exists. Within parentheses, we will pass the video path again. So if we do not find any path, we will just print error, file not found. And at the end of it, we will just return none. Next, we will call the video capture class of the CV2 library. So cv2.videoCapture, and within it we will pass the video path again, and we will store it into a variable named cap. Alright, so if the video doesn't open, if not cap, if the video doesn't open, then what we will do is we will print error, video not opening, and we will return none. Next, we will initialize an empty list and we will name it frame list and we will set it to empty. So what this list will do is that it will store all the frames that we will need in order to create the panoramic image. Next is the frame skip variable and we will initialize it to 10. So what this variable do is that it will skip every 10 frames because we actually do not need each and every single frame in order to generate the panoramic image from the video. So skipping 10 frames in the middle is fine as it is more efficient because it reduces the computational power drastically as we do not have to process each and every single frame one by one. The next variable is the frame count and it will keep track of the current frame number. So we will set it to 0. Now we will initialize a loop. So while true, we will call the read method of the CV2 library and we will store its output within two variables. So the first one will be red and the second one is frame. So what this method is doing is that it's actually reading the frame one by one. So if it succeeds in reading a frame, it will output two values. The first one will be Boolean value and the second one will be the image. So if it succeeds in reading a frame, that is it gets the image, then this red will be set to true and the image will be stored in this frame, in this variable. So if it succeeds in reading the frame, red will be set to true and frame will have the image. And what happens if RET is false, which means we do not get any image or any frame. So if not RET, then we will break out of this loop. And if we get an image, then as I told you before, we will skip every 10 frames and work with the next one. So in order to do so, we will write if frame count modulus frame skip equal to 0, and all the single frames that we get here are all huge in size. So this huge sizes are actually not good to work with while generating a panoramic image. So we have to resize those frames. So now we will create a variable. We will name it resize, and within it we will store those resized frames. We will call the resize method of the CV2 library. We will pass the frame here, which stores the image, and then we will pass the size that we want, which will be 614 to 360. Next, we will append this resized frames into the list that we initiated before. So frame list dot append, within it we will pass the resize variable, and finally we will increment the frame count by 1. Now the thing that we want to do is we want to release the video that we have been holding for so long, because we are already done processing the video and we have also stored those frames within the frame list. So we will now release the video using cap.release command. Alright, we are done releasing the video. Now we have to verify whether if there are at least 2 frames within this frame list, because if there are less than 2 frames, then we won't be able to generate the panoramic image from the frames. So we will write if length of frame list is less than 2, then we will print not enough frames to generate the panoramic image, and we will return none. Okay, so we are now done with the first part where we fetch the frames out of the video, and now our next part will be the last part where we will stitch those frames using the stitcher class of the CV2 library. So now let's call the stitcher class of the CV2 library, and there is another create method within that stitcher class. So we will call that, and we will store this within a variable named stitcher. Next, what we want to do is there is another method within this create method. We have to call that, and we will write stitcher dot stitch, and we will pass our list within it. So it will actually stitch those frames up and kind of combine them to generate a panoramic image. So stitching acts as glue, so it glues those frames up, so finally we get one singular image as the output. So it actually have 2 outputs, one is the status and one is the image. So we will write status and pano equals to this. Alright, so the output, the output will have two values. One will be the boolean value and the other one will be image. So if we are able to successfully stitch those frames up, then we will get the status to be true and the image will be stored within this variable named pano. But if we fail to stitch those frames up to generate a singular image, then this status will have the value to be false and there will be no image here. So this is how it works. So now what we want to do is, what happens if the status is false? So if the status is false, or we can write cv2.stitcher class, and there is a method to verify. Alright, so stitcher okay is a class on its own, and using this class you can actually verify if the stitching is completed or not. So if the stitching is not completed, it will generate an error. So we will write print error during stitching, and we will pass the status variable within it, and we will return none. We are done with the final part of the logical coding where we stitch those frames up in order to generate a panoramic image. Now the very last thing that we want to do is we want to display the image using the matplotlib library. But before we do that, we have to save our file as something. So we have to name it. Let's create a variable named path to pano. And we can name our file as anything. I will name it panorama output.jpg. Next, we will use the cv2 library to write the image. The image is saved as pano. We got it from here. So we will save this image as panorama output.jpg. So before it, we will write path to pano. And we will return the path. Before returning it, we missed one thing. We did not yet display the image. As I told you, we will use the matplot library to do that. So let's do it. I will write plt.figure. And we will set the fixed size, that is the figure size. And I will set it as 20 and 10. Next, up until here, we are using the cv2 library. So cv2 library normally processes images in the bgr format, but the matplotlib library in contrast uses the rgb format to process images. So up until here, our images are in bgr format. So as we want to pass our image to the matplotlib library, because we will be using the matplotlib library to display the image, so we will have to convert the format from BGR to RGB, because RGB format is the way or the format in which the matplotlib library processes images. So now we will change or convert the format. We will write plt.imshow cv2.cvtcolor, and within the parentheses we will pass the image which is saved as pano. And next we will use the method color bgr to rgb, which is the method of the cv2 class. So bgr to rgb. Next we will set the plt.axis, we will set it to off. We will name the title. I can say woohoo. Here is your finally we will write plt.show. We are only left with calling the function now. So before that, let's run this cell. We will copy the name of the function and we will now create a new cell and paste it here. Within this function, we will pass the path that we saved our file in. So we will copy this and paste it or pass it within the cell, the function. Let's run it. So this will take a good amount of time, so I will come back to you after it's done processing. We really got an error, and this is because of a silly mistake I made where I kind of mispronounced the word or the function name. So It says there is no such attribute as teacher, okay, because the name is not teacher, okay, it's teacher, okay. So we just have to add a T and let's run it again. Sorry for the inconvenience caused, guys, but we will have our output soon. Here it is, guys. We finally got our resulting panorama image that we processed from the video itself, and it really looks amazing, and it captured almost all of its frames without missing anything, and it doesn't look like it's overlapping any faulty frames as well. So we finally turned a simple moving video into a wide seamless panorama. You can use this technique for a variety of reasons, such as creating panorama photos from video clips, generating immersive content for virtual tours, or for cinematic effects on short films or advertisements. You can try it yourself with a variety of videos. Anyways, thanks for watching, guys. If you found this helpful, give it a like and subscribe for more exciting content. I'm testing out many new things which I will come up with soon. And also right now I'm continuing an applied machine learning black belt series where you won't just learn the theory but also apply the concept simultaneously. And everything is for free. I'll soon come up with the applied series for deep learning and NLP as well. So stay tuned, guys. I will see you in the next video. The Naughty Samurai signing off.